Oh,
Hi,
how are you doing?
pretty good. What about you?
Yeah, not too bad. I mean, look, weather's nice today. Like,
Oh, yeah.
you looked outside, or
I did. I mean, there was a bit of sun this morning, but
yeah, true.
been pretty gloomy since.
But it's crazy. Like in Central Europe, we have problems with like floods and water and whatever. And I'm pretty sure that you have like same problems.
I mean, we've had quite a bit of rain, but I haven't heard anything about flooding yet.
Right, right. I mean, it could be that just because of the mountains in our area that we actually have big problems with floods. But
Yeah, it'll
if
It
you
probably
is
go
probably
because
come
of
our
to,
the
way eventually.
yeah, true, yeah, that's true. Eventually, yeah. No, but it's interesting because I think in Turkey and so on, it's like it's never been so hot or something. They have like a heat. I think to give us some heat, and we'll give them some water and everything.
It's almost like we have issues with the climate.
Yeah,
Someone
it's
should look
weird,
into
isn't
it.
it?
Yeah.
Yeah, that's thought.
Hello.
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 Hi, Clement. I think we are complete, or?
Yeah, it's only
Yes,
four of us.
according to the agenda.
Okay,
Now we can
that's
make
good.
all the decisions.
Yeah, we have. So I have added. Sorry. I have added agenda items,
Oh,
Oh,
and we have.
I have another one, but yeah, I can add it.
Yeah, we added and up merge it. So because we are heavily writing spec text at the moment for the things we discussed, but there are always like things I want to verify before we invest too much textual work into it. Okay, so we let's quickly do a round of introduction just for future watchers of the recordings.
Hello.
It feels always awkward, but so let me remind everybody, by being here, we all agree to the GraphQL Spec membership agreement and the GraphQL Foundation Code of Conduct. If you don't remember, you can have a look at the agenda. It's linked there and get a refresher. I'm Michael Stipe. I'm the host today. And let's go in the order of the agenda.
I'm next. So I'm Camille from the guild.
I'm Martin from Apollo.
I'm Pascal from Turkey.
Awesome. Okay. I have added 3 topics to the agenda. Pascal will add another one, and we'll see what we can cover.
Yeah, I can cover it in field selection map in my first thing. So before we talk about the field selection name, we did some thinking and some brainstorming about patch and lookup,
Yeah.
and came to the conclusion that there are actually no internal lookups.
Okay.
There is only there are lookups, but internal fields can be lookups.
Yeah, but that was the outcome of the last meeting.
Yeah, I mean it's the but there is no concept of,
I'm a bit confused. Like, why does that mean there are no internal lookups? Like,
because it's two different things. It's completely separate. These concepts are completely separate from each other. Internal just toggles the field visibility
yeah,
of a public of a query field, and lookup means that it's a lookup. But
oh
these
yeah.
concepts are
But
completely different. There's
oh no, I mean,
there is
I agree they're different, but you can apply them to the same field, and I think that's
you
what
apply them
we were referring
exactly.
to with internal lookups.
Yeah,
Yeah,
yeah, but there's a lookup itself can never be internal. It just happens to be that these are applied to the same field. But anyway, that's like a big
yeah.
revelation for me. Anyway,
That was the outcome of the meeting last.
yeah, but we were talking about internal lookups, like the concept of public lookups and internal lookups, but
Yeah.
it's actually only lookups and public and internal fields. The lookup itself is never public or internal. It's just a lookup.
Yeah,
The field is public or
in my
internal.
mind, I think that was always the case, but
Yeah, that's where I'm at the same place now. Anyway,
okay, that's good.
the field selection stuff. I don't know if you've read the pull request about it.
Not yet, no.
We were thinking a bit about the field selection there, and think that the name probably is not quite fitting, because it's really a map from output fields to input fields, right? And when we were playing around with names, we realized that there is already a field selection set in GraphQL.
In the
And
spec, yeah.
yeah, there is no field selection as the name, but a field selection would be a member of the field selection set. Just
field selection
happens to be the field selection.
Yeah.
So instead of having the field selection as the scalar specifier, we could just say that it's the field selection map, because it's a map from output field selections to input fields. And then we would have the field selection set, which would just be the field selection set as we know it from the GraphQL spec. And then we would have these pair of names, which is quite nice. Otherwise, it's a bit lost. If we just call it field selection, then it doesn't make much sense.
Yeah, no, you're right. I hadn't considered that, but it's the name is taken. You're right. Yeah, I mean, field selection map makes sense to me. I haven't thought about it too deeply, but it, like, at first sight, it sort of, it makes sense for this concept.
Yeah, it's like this is not a make or it's more that if you find something better, you know, so maybe get feedback from your colleagues, then we can anyway change it. But this is what we go forward now in the specification text.
Yeah.
And if we come up with some better, like always, we can change it.
Yeah, I mean, my only concern would be sort of developer usability and education. Like, if we can come up with a name that's more descriptive, that's probably better. But it's mostly an internal name anyway, as it stands right now.
Yes, it's but it's there as a scalar in the specification.
Yeah,
and it depends a bit on the next topic, right? What we do with is.
How do you mean?
Well, yeah,
it is an internal scalar, so to say, but it could,
but you could use it. I mean, you use the field selection map scalar quite a lot. You never specified yourself, but you use it with is in lookups.
Oh no, you use it, but I mean, it's like many terms in the GraphQL specification. It's not something most users think about.
Yeah, the only place where people could actually use it is when they define the directive within the subgraph. So then, like the is directive, right? So they need to specify the name of the scalar and define the scalar. So then that's the only case I would say. It's not even like needed in some cases.
Yeah, and I think the expectation is that libraries would usually take care of
exactly.
Yeah,
that's why I meant it's hidden. Like, for instance, in Hot Chocolate, we will have a library that completely encapsulates that away, so the user would never see these directives actually in the way that he or she has to declare it. It's basically attributes that they put somewhere. So, okay, let's move to the next thing. That is the is directive. Or let's actually start with key coupling, as we I can quickly walk you through what is there. I reworked it a bit. first off, we had these person examples. So I made all examples now with product because it's a typical example that we
tradition.
have. Yeah, but it's also very, very nice example, very easy to explain to people, right? Reviews are here, products are there,
Yeah.
whatever. So I reworked it so we have also a consistent kind of theme in the examples, and then it's also easy to just copy something new into the examples without always thinking about do we now take cat stocks or whatever. So this is one thing I changed like in the spec, and I'm consistently working through at the moment. The other thing is about key coupling, and we had discussions on that. And that is, at the moment, we have a key coupling described here. And that is the argument of lookup fields must correspond to field specified by a key directive annotated on the return type of the lookup field. That is, at the moment, strict. But the other way is, like, if a lookup doesn't have a corresponding key, it's not useful for the gateway. It might be useful for other things, but not for the gateway.
Yeah.
As we are specifying here for the composite schema specification, I would say let's leave, like, my feeling is to keep it strict and then later loosen it up or even pull out the lookup spec as a separate spec.
Yeah.
But
I think my only concern would be like describing it as a validation rule might be more difficult for complex cases, especially if we start thinking about sort of the nested lookups that we talked about before.
Yes.
But we can definitely describe like a very strict validation rule for this first version and leave that for later if we
Yes.
I mean, don't you kind of have it in the end anyway through the satisfiability rule?
Oh yeah, but then you'd have to describe it in terms of satisfiability, which is a lot more complex, I think, than sort of a one-to-one mapping.
Yeah, that's true. But yeah, do we?
I think
the
it's probably the more correct way, but it's I'm not sure we're there yet.
Yeah, no, I like my thinking was, let's keep it strict in the beginning. When we see it is too strict, we can loosen it up.
Yeah, we also don't necessarily need the validation rule in the beginning. We can also, I guess, just say that
if it's in there,
match.
Pascal, we do a validation rule.
It can also be descriptive, like a descriptive remark in the spec.
Exactly, and then we can just wait, and if we decide to do it in the end, then we can add the validation rule, because if it's complex, we could just... some of the validation rules, if you look at, for example, the input validation rules in the GraphQL specification, it's literally that for each field, there has to be a matching field or something like this. So it's really, it's like 3 lines.
Sure.
So we can also make it simple like this, right?
Yeah. It was not about making it complex, but if we say this is what we expect, then we don't have to deal with additional text later that explains that only lookups that have a key or that all lookups that don't have a key are basically being dropped or something like this. Because this kind of already validates the state that we want to have and how we want to have that manifested in the schema. Okay, so this is the
also one question. So for example, I guess the rule could be that, like, if there's because both the object types and interface types should have a lookup, right? If it has a key, then it's resolvable. then it has to have a lookup, right? Matching. So then, because I'm thinking, if there's a case, if let's say we have like product and like, or let's say an animal interface, right? And then we have like a dog and a cat, right? So then the interface itself has the key field. I mean, it's an entity, right? So it has to be resolvable. But is it possible that like the dog, let's say, is an entity and implements the interface, which is the animal, and yeah, also has the key, but it is not resolvable directly? That's fine with the spec, I believe, right?
I don't know if I got your example
Yeah, because
correctly. Do you mean something like this here, where we have two types and the union?
yeah, that's a union. But what I mean really is the like in Federation, for example, right? You can have an interface that is an entity and it resolve itself, right? And then it resolves into either like, you know, a
Something like
dog
this.
or a cat, right? But is it possible to actually have one of the members of the interface that is not resolvable? I mean, specifically in Federation, we have
I
the
think
key.
so, because I think it works the other way around, the validation rule. Like if there's a lookup, there has to be a corresponding key, but there doesn't have to be a lookup for every
Exactly.
key.
Yeah, that's why I'm asking,
So
because
for instance, you could have just like a node root field, and have every entity implement node. And I think that would still validate, right?
Yeah,
that makes
it's more
sense.
like so when we have here a lookup for this ID, it doesn't necessarily say that each. Maybe this is something that we also have to specify. We did.
Why?
We did. Yeah.
Why would the this would in 1 second. This would if you define the key on the node interface, this would inherit it to all of the childs, right? So all of the childs are actually also.
You still need to annotate the
yes,
the implementing types as well.
That's also described here.
But you would. Yeah, but it would be invalid to have a node without the same key, right?
Yes.
Yeah.
Good. I mean, in that case, it makes it really easy because if node has annotated the key ID, all of the childs also have to have the key ID, which means that this lookup is a way to fetch all of the nodes. And if node doesn't have annotated the key, then it would be only a lookup for all of the childs of nodes that have annotated the key ID.
Yeah. What I really meant is contributing to other types. So for example, if you have like a dog with a key, you know, then if it is not resolvable, it means that it cannot really be used directly to add fields to the entity, right? There is in some other subgraph, right? But the interface can, right? So you can actually contribute fields for the interface between subgraphs, but not directly the entities. And the entities, the object types, you know, are there because they have to match the interface, but it doesn't really mean that this is like they have to have the corresponding lookup, right? So I feel this is the correct behavior, and we should like follow that, I believe, because that's one of the cases that could be useful. So
yeah. I think one complication that I think we decided to leave out of the first version of the spec is in Apollo Federation we have the notion of an interface object,
yes,
which also works for these cases. So it's a way of, for instance, if product, or let's stick with the animal example, you can have a subgraph that only knows about like the animal interface basically and not about any of the implementing types, and then in that subgraph you sort of you make product an object type, and you can add fields to it, and those fields are then sort of in the supergraph are available on each implementing type. So it's the same mechanism.
It's quite useful.
Yeah, it's very useful. It's a bit of a weird sort of workaround, because in GraphQL, like you always need to be able to resolve to a concrete type,
Mhm.
But it's definitely very useful.
Yeah, you don't have like, but it makes sense because GraphQL is not a language where you implement things, just the description, right?
Yeah.
Yeah.
So I don't think anything in this sort of precludes adding that later. But
No.
but just because Camille was mentioning that use case.
Yeah.
Yes. And like, yeah. Yeah, I mean, we will add anyway later. We will have a look at interface object for the functionality, and then we see how we spec that down.
Yeah.
Like we need to, like I haven't fully looked at it. I need to read into it what it actually does or what the intention is, and then we can like put it in a 1.1 or so. I don't know.
Yeah, we can like deal with it later, I believe.
Yeah, it's. I think it's important to have a first version that covers a good portion of it of what is out there today, and then we can iterate. Like once we have the initial piece out there, iteration is much more simple, like adding new directives or things to it. Okay. Yeah, so I also added, now I rewrote internal, by the way. Internal is now only on field definitions because it only makes sense on fields and on lookup fields. It makes sense on both. Like you could also say, I have here an internal product ID.
Yeah.
And that is a key, but it's kind of a hidden key. And then internal also makes sense. Just this subgraph provides it. And also specifically in the case of lookup makes sense when you have maybe this subgraph is the review subgraph. So it provides an entry point for reviews requests, but it also can contribute to product, but it's not the entry point for product. And that's also how I describe it. I have to go over the text and also add some more notes to it. Like what we mean really with entry points to the thing. But yeah, this is already a rough outline that we have a new understanding of what internal is. I also will now add, we'll do that later tonight. I go to the Apollo documentation and just steal the inaccessible back. So because like at the moment, internal was what inaccessible was. And now we have internal for this thing, and then we have inaccessible, which is now 2 use cases essentially.
Yeah.
Okay. So the last thing, and
I think we have some hands up. I don't know if they're related to this
go
section.
ahead. So sorry. Go ahead.
Pascal was first. So.
Yeah, we make the queue again. The queue.
Yeah. I was not paying attention.
Don't worry. Just out of interest, if you flag the internal ID as internal on one subgraph, and you have the same field not internal on another subgraph, is this still considered the same field? So would you allow to expose the value from the subgraph where it is defined as internal?
You would, but you would also have to mark it shareable.
But it's on an entity, so it's shareable by default,
yeah.
right?
It's key
it's
field.
shareable.
Yeah.
So shareable, I guess it's only if it's a key field, right?
Yeah.
By default.
In this case, it's a key field.
Yeah.
So
that makes sense. Yeah.
Right.
Yeah, so that's actually the reason we also have inaccessible. Like if internal ID, if there's a strong requirement for it not to be exposed, you want to mark it inaccessible, and that precludes any other subgraph from exposing it.
True. My question is more about the value from the subgraph where it is internal. right? So if you make it internal on one subgraph, does the value from this gets exposed, or does the value always get exposed from a non-internal subgraph? But
From
when
the
we consider
non-internal-
it to be
from the non-internal, because like in that case, you use internal to steer.
yeah,
Well,
that's
the
exactly
query
my
planner could
question.
still decide to get it from this subgraph.
Yeah,
Yeah,
is it,
because-
is it semantic? Yeah, it's semantically.
That's what I would. That's exactly the discussion I had in my head. It's semantic. If we consider it semantically equivalent over multiple in the domain, then it should be fine, right?
Yeah, I mean that's the whole idea of shareable, and then key fields are sort of shareable by default. So the idea is that it shouldn't matter which subgraph you get a key field from, but you still need an entry point, of course. So in this case, there might not be a lookup that's there might only be an internal lookup by internal ID as well. So in that case, you'll always go through another subgraph first.
Yeah, also because this one is internal, right? And we want to have two directives or just internal, because we're referencing internal and ineffective. Yeah, so this one says that it's like hiding
internal for one
field.
sub. It's basically internal data that this subgraph exposes to the gateway or the executor, but not to the public. So it's essentially metadata, you could say.
I know. Just trying to figure out what is the difference between like internal and inaccessible, because inaccessible hides it from the public schema, and this definition says that it also does it for internal.
It does, but it doesn't stop another subgraph from
exactly.
exposing it without internal, and that means it would be added to the subgraph.
So basically, with internal, you need it on all subgraphs to be removed. With inaccessible, you only need it on one subgraph to be removed on the topics.
Yeah,
but we would have to define it in this definition a bit clearer, I believe, because it says that like the annotated field definition are not intended to be part of the public schema. Yeah, so it doesn't say that, you know, like I don't know. I would add.
No, I agree. And I think if we add inaccessible, that's also a good point to sort of describe the differences.
Not intended to be part. Yeah, that is a good remark. I will add that.
Because this one was like confusing to me, because then I thought that like internal is actually inaccessible. So yeah. And also one question about internal. Yeah, internal is like, because it says that it's on a field definition, right? So now we have like, I have two questions, right? One is an interface type field,
also a field
right?
definition.
But I mean, if we actually want to have it there, right? Inaccessible, for example, in Federation, I believe it's not accepted on interfaces.
I'm not very sure.
I would say it is accepted on almost any.
Because if it's like, because if it's an interface, then this field won't be exposed as part of the interface. But if somebody is actually querying the object type directly, should it still apply or not really?
Not quickly.
So that's the second question. And then the third one.
Yes, allowed on interfaces. Or do you mean fields? You mean fields, interface fields? Okay.
Yeah. I think if it's allowed on interfaces, it should also be allowed on fields of interfaces, because putting it on an interface just means that it applies to all the fields in that like type within that subgraph.
Okay,
but should the object type inherit internal, or should it be only when the interface is referenced?
I think it's only partly. It would only remove the field from the interface.
That makes sense.
Yeah,
and also.
I made that really. So I made this really tight because, like, I couldn't see at the moment the use case for having two broad ways to flex something internal. And if we keep these things tighter at the beginning, we can also if we find a use case for something else, we can add it. But at the moment, it's really, this is the main use case, and this is the other use case that I found can be useful.
Yeah, but I do agree that it's probably a better example of inaccessible, if you really want to keep that ID internal.
Yeah, I mean the thing with the it's the prime example of inaccessible, right? It's the one from the documentation even.
The internal ID.
Yeah, I mean, I always thought about inaccessible as the the easiest way to make the schema to evolve the schema, but I think that it also makes sense to share things that you do not want to. I mean, in federation, it's definitely used like this because that's how you share data between subgraphs. For stuff that you really never want to expose.
Yeah, so the way I thought about internal IDs is that they sometimes are not semantically the same. Like you could have the same internal ID on two subgraphs, but they are actually, if you mark them as internal, it's something that I am doing here on my subgraph.
But
that's the way I thought about
that's
that.
definitely not the way it's currently be implemented.
Yeah.
It's worth thinking about, but it might get confusing with the shareable semantics.
What's interesting with that would be that then in this case it would never be a key.
True. Yeah.
Because if you have it only on this subgraph, then it would never be a key. Because for it to be useful in a key, you would have to share it. But it's an interesting idea because if you think about it, we use internal to hide basically lookups. To hide fields on one service. And what you could do is you could even use internal for traffic steering if you want to say that I have this data, but I don't really want to expose it. Because, for example, it's very expensive to fetch it on this subgraph or something like this. But
I mean that's not how it would currently work, I think. But it's.
I mean, it kind of is.
We might be trying to pack too much into
so
it.
we can also as that we can also make it in the first iteration really about lookup. Internal is for lookup.
Well, it's also for required fields. Like that's the other use case.
Where do we need it there? Yeah, well, let's see when we
if a subgraph like has a require directive on one of its field arguments, that require argument can actually reference internal fields of other subgraphs, but they wouldn't be directly exposed.
Yeah, but isn't that also inaccessible?
Yep.
External, I think.
Yeah, I mean, we currently implement that with inaccessible.
I mean, I think we have to rethink what internal really is, right?
Internal is clear. It's internal to one subgraph. Is one thing that is on one subgraph and is not exposed to the other subgraph. That helps with this thing.
I mean, it is exposed to the router.
Yes, that's why I like internal more than internal more than private, for instance, because private is okay. That's not even the router. Like it's like a protection level in Java, right? You have package internal members.
Then what? Just to to throw the idea around. What if we only have one internal, but it would have an attribute to make it globally?
Like a score.
We discussed that, but
yeah, but I don't
like we can discuss it again. So it's up for discussion. This the question is, so in general, I have come to dislike these arguments where we have global. True. I mean, it's a protocol. It doesn't matter. We can wrap it to the outside differently.
Yeah, I think it's also, I mean, it's simply it's more typing, but it's also a bit confusing because now you have to explain not just internal, but also global and non-global internal.
Yeah, I know, but the only
and inaccessible, I think, has the right connotation. Like it has a really strong meaning. It's completely. And it also has a different purpose. Like it's really saying, I never want this field or even this type the way it's currently being used.
Yeah, that would
goes to clients.
Yeah, that doesn't work. That doesn't really work with lookups.
No, and we don't. And that's why it's good we have another mechanism for lookups. And internal, I think, is the right term for that use case.
Yeah, I mean, I said it back then. The only thing which is a bit confusing is that we have internal and inaccessible. So I think it's just two things which are really similar but are different.
Yeah, they are very different actually.
Yeah,
the
but
more I think about, they are very different. Yes,
they are very different, but they sound very similar. So the impact of choosing one over the other is really big. But the main issue is that even if you have one subgraph and you flag a field as internal, it has the same effect as inaccessible if it's only defined on this subgraph, until a second service adds the same field without internal, and only then there is a difference. That's even more confusing. If you have a subgraph product and you flag on the product subgraph name as internal, the name is gone on the public schema because name only was on the product subgraph.
Yeah, that's why I said we can make it strict, only use it for lookup at the moment, and then we have time to come up or not come up with anything else, and it maybe is just for lookups.
It might be good to start out with that. Yeah,
because like we don't have to have like the tighter we keep it, we can always add use cases to it when somebody comes up. In this case, this thing is really useful. So we could first really make this a thing for lookup, and say, okay, this is the switch to make lookup something that is exposed, that is an entry point, or is no entry point. It's also much simpler to describe, like and then we have a validation rule. If internal is used anywhere where there's no lookup, we just say this is not a.
I mean, would this be a valid case, or is this just crazy? Like inaccessible, in this example, inaccessible is for hiding stuff that you really never want to get exposed. For example, PII data on a public object that you need to share between subgraphs. You never want this to be exposed in any case. Now, there are cases where you have stuff on types that you may define, but another subgraph may like to expose. Like, for example, if you have a field where you cannot validate if a user really has access to, but you can still consume it in a key, then it could be internal on your subgraph, but it could not. It could be that another subgraph exposes it.
That's
because
Pascal. It's like we are looking for a use case. Let's rather make let's use this for the thing where we already know we want to use it for, and kick out the other stuff. And I think then we are good with that. The simpler we keep it at the beginning, the more space we have to expand it to, and we don't create now a burden that at the end might bite us.
Let's kick it out. You're right. Let's
just kick it out.
Let's say it's only allowed in combination with lookup, and then we'll see what we'll do in the end with it.
Okay.
Because if we end up only having it like this, then there might even be a better way of doing it.
So everybody okay with that?
Yeah.
I think that makes sense for now. Yeah. And we can always keep thinking and something might come up, but but it's good to restrict it to this concrete use case that we actually know we need.
And I would also keep us open for the new name of the internal or inaccessible, because like those two are like very similar, and it will be hard to teach. And even like from a point of view of like, you know, if you read a subgraph, you want to like, you know, you go through the fields and see, oh, internal, you know, and then you have to think, but it should be like obvious. And then you always have this like, you know, I need to really think, is it internal or is it like inaccessible? For example, in Federation, there's a directive called Composite directive, and I never know if it's composed directive or composed.
I always thought that.
And that's like, and I seen like, I don't know, thousands of, you know, subgraphs and stuff, and it's like, you know, so that's why I'm thinking, you know, that for us it might be, you need to, there's a learning curve, but also maybe we can make it more easy for people to like distinguish immediately. You know what I mean? So that's why, like, let's keep it open for discussion, I believe, the name.
Yes.
In future, not today.
All names are up for discussion. Yeah, all names are up for discussion. And if anybody from us comes with a new idea, says, actually, let's call lookup whatever, then we discuss it and see. As long as there's no first version of this, we can still change any name. So if you guys have
I'm just, if we use internal really only on lookup, then maybe an argument would be the wiser choice. No,
I don't think so, Pascal. Because like from a spec point, lookup text, lookup specification would get longer and longer and longer, and not focus actually on the thing that lookup does, and that is being a function, marking a function, if you will, to resolve an entity. And this is to hide that function from the public.
It's more about directives are an unordered set.
Yeah.
So there's no order.
And
so lookup and internal, as it is two directives, they're two distinct things, but they can always.
I don't think it matters in what order they apply.
Yeah.
I mean it's
aspects.
Yeah.
Think about a class in C#, for instance. You can order it however you want.
Yep. Yeah.
Public, internal. You can order it however you want.
I mean, if we could write the internal before the field name, that would be really nice.
But that's a
private.
That's a choice. But it has nothing to do with interpretation.
Yeah.
This makes it an internal lookup.
Yeah. Okay. Whatever. It is what it is.
We move on.
Let's move.
Yeah.
Okay. So the last thing I'm so I will rework this, and we will have a look at next week at the new version. And so I'm at the moment on this part, and that's why we also need to decide for this guy here, right? This is the field map. I have rewrote is to only apply now on arguments. Before it was like in Fusion we used it everywhere. You could also just go to a random field and say this field is actually this field on this subgraph is the same as on this type, this thing, right? At a much broader focus. But actually is now or has now this map here, which describes how the output data is mapped into the input data. We could also consider a different name for is and say it's map. I don't know. It just came when I started. You can see I'm still in the sentence. It's not anymore just semantical equivalence. It also describes semantics of keys, right? Like how this argument maps to this, but it also describes at the same time the mapping logic.
Yeah. Yeah, I get what you're saying. I think one of the issues I see is that it's not just about the directive name, but you also need an argument name.
Map key.
And map, well, it's not map key. And map field is not exactly like you're not just mapping a field, you're actually describing a map.
But don't you map a key?
No, it could be, it could.
It's individual fields, and not the whole key that you're mapping here.
It could be mapped with. I don't know.
Yeah.
But this is.
I mean,
I agree. This is the map, right?
Yeah.
If we make it right, this is the map.
Yeah, but then it's sort of nice that we have consistency with the argument name. Like we have like require field and we have is field, and then field sort of signals that it's this scalar that we're using.
But in require, it's also the map.
Yeah.
It's also wrong in require.
Because require use the same syntax. So it's also a map syntax that tells us how output data from somewhere maps into this requirement.
Yeah, but you're requiring a single field. Like it always describes a mapping for a single field.
Yeah, also. It's always a single argument.
Yeah.
But it could be a graph. Like this could be an input object.
Oh, sure. But then you're still mapping like that field. It's just that the type is complex.
Yeah, but you also it's very easily we use the word map here. We're mapping because we are also describing. We're not just so before it was basically we point just like this, right? But now it's also we point, but maybe also say where it comes from, and we can kind of also pull things up and down. We pull things up, down. Yeah. And we also have, like, think about this case where it's addresses. And then we have even like this kind of map. Like it's very powerful. And that's why it's not anymore, we have a field where we point to. We have here mapping logic, really.
Yeah.
It's a real mapping expression that we now have.
I mean, and especially given the field selection map name, it might make sense to see how it feels if we replace field with map. But I would definitely do it both for is and require in that case. I think we need consistency between those two.
Exactly.
And then the thing also doesn't make the map key also doesn't make sense anymore, because in require it definitely is not a key.
Yeah.
Yeah, so this here, it's not. It doesn't sound bad if we make it a map, right? Idea. This is the map. I don't know, but yeah, it's not something like maybe you can also crunch it.
I mean, yeah, I mean, it's sort of we have complex syntax that we allow, but the simple case I think is still, for instance, like renaming it, like saying field is like person ID, and in that case, field, I think.
In this case, I agree. I agree with you. In this case, it's a very distinctive example, and it's very easy to read.
Yeah.
But I kind of why I started struggling with this is because I'm writing the spec for it, and there we have suddenly I'm describing that this is actually a mapping syntax. And we are describing the map between the output and the input.
Yeah.
And that's where I started struggling there, because before it was like, it just told essentially the composition that two things are the same. And then if two things are the same, we can just internally map them still. But it was more about to tell the composer that these are the same. Messages, chats. Is or are.
Yeah.
Okay.
I mean, it's still, it always describes a single value. It's just that the value might be complex, but you're still mapping a single field argument, right?
Yeah, sure. That's correct.
I remember, didn't Shane once propose to ditch either require or is?
Yeah, no. Pascal.
Yeah, but 1 second. What was the argument back then? It was the semantic equivalence that is expresses, right?
I think it was more about trying to avoid sort of multiple directives, like having to interpret the lookup and the is on the field arguments. But I think we've sort of moved beyond that.
Yeah, and I would also not. It's very difficult to describe also that require, for instance, has two distinct functionalities.
But I mean, is it?
It is. We have to describe the case when it's a lookup, and how require also describes here the mapping, essentially the mapping from keys into.
Yeah, it's different because you would search for the values on the query type if you would have the same definition, which would be wrong, obviously.
Yeah,
that it's two different things.
Yeah, it's
which you have similar but different.
Yeah,
that's fine.
Yeah, it's nothing. But if something comes in your mind, I will start describing it with the functionality. We can leave it for now as field. But maybe we come up with something better. It was more about, okay, I was struggling a bit with the naming and the changes we did to it.
Yeah. Yeah, and sometimes I really wish GraphQL had had directives with anonymous arguments.
Yeah. Do you know this? I don't know if you know this. We now have pragmas in GraphQL, or they come.
I didn't even know this. Yeah.
And you can do this. Then you so you don't need. So first off, pragmas are per document, and in each document you have to reset them. We will introduce them for semantic nullability, because with semantic nullability, okay, let me show you, because I also have thousands of use cases for pragmas now. Just
As it
don't
is with
have-
the new language features, like you
Yeah.
throw it against everything and hope that it sticks.
look, yeah, but like we have a broad agreement, or broad agreement. It's not yet accepted, right? But it's the current proposal, and with everybody we talk to, it's like well received. Let's say that. So, and that's always a good sign. Let's say we have here users, and users has maybe here these non-nullability, so it will never be null. And then we have a user, and that user maybe has an argument, whatever. And that user could be null because you could pass in the wrong ID. So the problem with this is if this is in a deeper nested type, we always have this problem of null propagation, which is bad for the clients, right? And actually you want to have a way to express semantic non-nullability. So an error, it can be null, and the client then knows what to do with it, or strict non-nullability. And there was always a problem, like we didn't want to introduce a question mark because like the default case should be nullability. But this is so nice for non-nullability, but it would be nice if we could give it a different semantic. So the idea is now, if we have now a pragma here, and we say, and this is also a valid pragma, for instance, semantic nullability on, for instance, then this is no longer an issue when there's an exception thrown. This is now a semantic non-null. And if I want to have now a strict non-null, then I can do this. Like, I really don't want it to be null, right? Very explicit. And the cool thing with that is, like, if you want to upgrade a GraphQL server, it's basically one of these lines, and then you have the new behavior. You can also do a replacement before you do that from all the exclamation marks, but the opt-in is now very easy to do. But this, like, but specifying this allows, like, for a lot of new switches that you can use. And also, if you think about a topograph document or a whatever document where we always misused the schema directives, kind of. We always used an extend schema because we wanted to bring something into the document, but we couldn't just leave it unattached. So we, and this allows now to place these.
And is there like, is it always like a key value pair, or is it like freely interpretable?
So let me.
And is there some RFC or something?
Yeah, there's an RFC. I cannot. I don't know because if that is already public. But Benji, I can forward it to you later. I just don't want to show the internal links here in the stream.
Oh yeah, of course.
But I can forward it in the group.
Yeah, I mean, it's definitely interesting because we have our whole like link mechanism built around schema directives currently. And there is a need for sort of more complex content in there. But if we can make sure that Pragma also works for those kinds of use cases.
Yes, it's the right time. Like how this works is certainly up for discussion, but for semantic nullability, we need like such a switch or such a functionality. But so I'm not like, I'm following the semantic null group, but I'm this was one of the takeaways. I was like,
out of curiosity, what's the reasoning for like a completely separate mechanism as opposed to like top level directives, for instance? Because those already have like typed arguments.
Yeah, but okay, that because it's per document. Like if you have multiple GraphQL document, it might be that you want to switch into a feature for this document, but not for the other document. But
yeah,
semantically,
that's
with
always
the
how we would interpret
yeah, but
document
like
directives.
yeah, but from a GraphQL spec standpoint, if you put on the extend schema directive, it's for
Yeah,
all
no, but
the
I mean,
documents.
I mean, as an alternative, like, and I think this has been proposed like many years ago, I think by Johannes from Prisma. It was like the idea was like top level directives, like directives that are not on the schema, but that are sort of at the top level. And those could also have the same sort of document level semantics, I think.
Yeah, so we could, like I said, like we can certainly get into the discussion with the thinking. Like that's at the moment a proposal by Lee and Benji. They did that, like in many languages, like a C#, it's actually the same syntax. You have these pragmas per document, and I think my guessing, I was not in the discussion, is that it's because other languages do it like this. These document kind of, okay, I have a couple of features for this document, but I forward you the document.
Yeah, I would be very interested in hearing more about it, because the problem I see with it is that you then have to describe like how to interpret those pragmas. So either there's like a simple key value syntax, or like there's something more complex. And with directives, we already have like type safe.
Wait. Benji gave me something. No, this is actually what he sent me. I didn't put it there.
Okay. So it does have the same semantics as directives. At least that's how I would interpret it. Yeah. Okay. That's a more direct mapping also to what we currently do with.
Yeah, and I will after the meeting I sent you the link. It's a Google Doc.
Yeah. Well, I'm glad we're addressing this, but yeah, let's.
Yeah, it's like it's like the, I don't know, 10th iteration on this specific proposal, but it will bring this feature because it's needed to make this other feature work. But it's like I see so many use cases for non-bound directives or pragmas or whatever we have.
Yeah. Document level directives.
Yeah. It could also be that they had some issues with the location of directives and the parser. I don't know. I'll send you the link. They had a lot of discussions also with the Facebook people in there. I think Apollo is also in there in the discussion from the Kotlin teams, one or so. Because like the relay team and I think the Apollo Kotlin team are in the discussions.
Okay. Yeah.
But I forwarded. Awesome. We are over time, I think. And this was just came to mind because I already see use cases also for us in that. Like if we want to tackle a couple of things, could also misuse it for namespaces.
Yeah.
Yeah. Let's see.
Let's not open that kind of worms right
now. No.
But...
Yeah, it was just on my radar on this side.
Yeah, no, I mean, but it's definitely one of the use cases we use schema directives for that.
Yeah.
Well.
Okay.
All right.
Okay.
Thank
Great
you.
meeting.
Yeah.
See you all.
Thank you so much again.
See you in a week.
See you next week.
Bye.